that we're live. And we're live. Okay. So today we are going to start our new unit. And in our new unit, we're going to be, I need that piece of paper. We're going to be talking about some reasoning skills. This is gonna be a real short unit, maybe a week, and then we'll have another test. Okay, but because it is a short unit, and because we're gonna go through it pretty fast, you guys probably need to be really paying attention. Now, having said that, when I look out, for the most part, most of you are just staring at me. Like you just come up and watch me work, and you just look at me. You guys are going to have to get more interactive in your own education. And one of those things is taking notes. I don't require you to take notes. I don't take up notes. I don't grade notes, but you need to take notes. You need to have something to refer back to. Y'all need to put them Chromebooks up, okay? You need to have something to refer back to whenever you're working that you can look at to see what things mean. So if you have a notebook that you're not using, or if you have loose leaf paper, or if you have a piece of slate, I don't care what you're writing on, but it needs to be something you can hang on to and keep up with, okay? You need something to take notes on, all right? Okay, so I'm going to give you a minute to get your stuff together so you can take some notes, because you're going to need to take a few notes today, okay? I wonder what would happen if I pause during me. Oh, I can't pause that. I can just stop. Huh. Well, I guess that won't do nothing then. Now, boys, y'all need to hang on to those papers, okay? So it's not a one-time use only thing, right? Like, I'm not asking you to take notes for me. I'm asking you to take notes for you. So when you need that information, you can go back to it, okay? Okay, y'all ready? So today, this is Unit 2. We're starting Unit 2. We're going to start with talking about the word conjecture. Now, if you were a betting man, what would you guess conjecture means? Now, remember, nobody knows the answer to this but me. So, best guess. What do you think conjecture means? What do you think? Anybody want to throw anything out there? I'll use it in a sentence. Make a conjecture about each value or geometric relationship. Like an inference? Good. A guess? That's good. So basically, what a conjecture is you're drawing a conclusion. You're drawing a conclusion based on the information that you have in front of you. Now, sometimes your conjectures will be right and sometimes they will be wrong. But you can only base them on what information you have. Okay? All right. Now, I'm trying not to show you all, but I'm trying to write all this again. Counter example. That's our next new word. Counter example. You better write this one down because you're going to use this one a lot. What do you think a counter example is? Best guess. Counter example. Y'all got nothing? Yeah, what do you think a counter example is? Okay. No, but good try. I appreciate the effort. What do y'all think? A guess? Okay. An example against something is exactly what it is. So a counter example is an example that proves something's not true. So a counter example would be an example. Let's say, for instance, if I said, Jonathan always wears a mask. Can y'all see him right now? Yeah. He's not wearing one, right? Right now, at this minute, that's a counter example. Now he is, But just because he is right now doesn't make it always true. So a counterexample is an example that disproves something is always true. So basically, it's an example that just shows that's not true all the time. For example, if I said all prime numbers are odd numbers, is that a true statement? Do y'all know what a prime number is? A number divisible by 1 in itself only. So like 3, 5, 7. Not 8, because 8 is divisible by 2 and 4. What about 9? Is 9 a prime number? No. 11 is. Okay. 13 is. Is 15? No, because it's divisible by 5 and 3. Okay, now let's go back to my statement. We got an idea of what prime numbers are, right? If I say to you, all prime numbers are even, is that true or false? That's false. What is your counter example? What is the example that you can give?
13 is odd.
I made the wrong statement when I said that. Let me backtrack again. What I should have said was all prime numbers are odd numbers. That's what I should have said. Okay? Now, is that true or false? I will tell you it's false. I will tell you there is one counter example. There is one even number that is a prime number. Two. What's 2 divisible by? 1 in itself. The number 2. Every even number is divisible by 2. It just so happens that if you're talking about the number 2, that is what itself, right? So it's only divisible by 1 in itself. That makes it prime. The number 2 is the counter example. That's the example that proves my statement is not always true. Okay? Now, the rest of these are words that you should already know. They're from Unit 1, but we're refreshing your memory to make sure that you remember them, okay? So here are the rest of them. Collinear. What's that? Points on the same line. Midpoint. Points in the middle of 2 points. Now, it's right smack dab in the middle, right? Adjacent. Yeah, so adjacent means they share a side. Like my room and Mr. Lester's room share this wall, right? Congruent. They're the same size. Complementary. What's complementary? 2 angles that add up to 90. Do they have to be adjacent? They don't, right? What about supplementary? What does supplementary mean?
2 angles that add up.
Y'all see those little symbols right there? Those little symbols are called ditto symbols, and they mean same thing as up there. That's what they mean, okay? Linear pairs are the last one we're going to talk about. What's a linear pair?
2 adjacent angles.
Good reading, Zaylee. 2 adjacent angles that are supplementary. They have to be adjacent, and they're supplementary, and that makes them a linear pair. And they make what is known as a straight line angle. They make a straight line angle, okay? Okay, so that's our refresher from our Unit 1 that you need to make sure you know. See, all this stuff keeps building. So we can't just like do Unit 1 and forget it, because we're going to use the information from Unit 1 to do everything all year long. Okay? And we'll keep bringing it back and bringing it back and bringing it back. Y'all almost good? Need another minute? Okay. I'll give you a minute to get those down. I'm freezing. I need to get my sweater.
Where's my sweater? Oh, my sweater's on my chair.
Uh-huh. Look this way. Is that good, Anthony, or I need to go more? Huh? What? Oh, can you see it? I'm working on something. I had an idea, and sometimes when I have an idea, I have to like write that second, and so it was my conference period, so I spend a few minutes playing with it. Sometimes I can just make a note and come back to it. Sometimes I have to right then, like try to see what it's going to turn out like. I can't get the skirt right on it yet. It's going to say Sassy Squatch. Huh? Engineering. We are going to look at the different methods that people use to create their shape yesterday. And then we're going to try to create some more shapes.
I don't even know how I did
You don't know how you did it?
it. Like, I was just like doing it, and like I made like a smaller rectangle to go on the side of it, and it just like connected.
And it attached because you, and I'll explain that in 5th period, but because you used part of that shape that you had to start with, shape 1, as part of shape 2, it automatically connects them. Now it only does that with primitive shapes though. So when we do some more advanced shapes where we're extruding and stuff, I don't think it'll do it. At least an inventor wouldn't. I don't know Fusion well enough to really say that. But I saw so many different methods yesterday that I didn't even think about using.
Mine's upside down.
Yeah, that's all right. Okay. Y'all ready now? Okay, so now we're going to our skills practice page, okay? So look at those first directions. They say write a conjecture that describes the pattern in the sequence, then use your conjecture to find the next item in the sequence. So when it says write a conjecture, that may mean write a sentence, like you write out a sentence, and it may mean write a mathematical sentence. Y'all know you can write math as a sentence, right? Where you use symbols and equal signs and numbers and stuff to make a mathematical sentence. This first one, it's going to have to be a real life sentence. So if you were describing this pattern to someone and telling them what to do next, what would you say? What's happening? Number 1. So it is getting bigger, but we got to be more specific. Because if you're showing this to Jonathan, or let's say you're not showing it, let's say you're describing it to him, and he has to draw the next one, how are you going to tell him what to do? Attach what? Be specific. Okay, attach a square. 1 square? We're going to just attach 1 square? All of the squares? So I'm going to draw a whole bunch more squares. 2 more squares. So I'm only going to attach 2 more squares. So I attach, where do I attach them at? Here? Do I put one here? No? See, you're not being specific enough. You're going to be more specific. Y'all can help him out. Don't be silent over there. He's at least trying. How are we going to attach squares? What do we do? To the end? Okay, so like this. Is that right? No. What? Okay, about the side of the end, like this. Okay. and not those. I probably should not have used a pencil. So just 2? I just add 2 on?
Then you have 1.
Oh, and then you add 1. So I add 2 that are shaded, and then I would add 1 in the center that is not shaded. Pretend that's not shaded. Okay? All right. To me, these are the hardest things to describe. They're so hard to describe. All right. 2 is going to be a lot easier. What's your conjecture for 2? What's happening in 2? What do you think is happening in 2?
Numbers are being
What's being added? Is 3 being added? That's what Zaylee said. Is she right? You think so? Well, let's check. It is 3 being added? Okay. So what would we say as a conjecture? We would say something like, to get the next term, add 3 to the previous term. Okay, so you would say something like that, okay? Doesn't have to be exactly worded that way, but that's the general idea. So what would our next term be? 11, because we would do 8, 9, 10, 11. 8 plus 3 gets us 11, right? Okay, what's happening on number 3? I'm not going to make the 20-minute mark, I'm just saying. What's happening on number 3? Now, sometimes looking at things like these fractions is hard to do, right? What if you made these instead of an improper fraction? What if you made them a mixed number, where it's a fraction, a whole number and a fraction? You know what's happening? So Zaylee says we're subtracting a half. But let's go ahead and look at, what would this be if it wasn't 11 over 2? Like, how could we rewrite that? 5 and a half. What would 9 over 2 be? 4 and a half. So now it makes it make a little more sense, doesn't it? When we're not looking at them as mixed numbers. So what's the next number going to be? 3 and a half. But we need to write it the same way they did. So how do we write 3 and a half as a improper fraction? Do you know how to get there? So what we need to do is multiply 3 times 2 and add 1. So what's 3 times 2? Plus 1. So that would be 7 over 2. 7 halves. All right. What's happening on number 4? Awesome, Anthony. Yes. Multiply by -2. So every time we're multiplying by -2. So your conjecture would be to get the next term, multiply the previous term by -2. That would be your conjecture. What would our next term be? So if we multiply this term by -2, what are we going to get? Positive 64. Right? Positive 64. Okay, so let's look at 5. So the next set of directions say make a conjecture about each value or geometric relationship. Okay, so 5 says points A, B, and C are collinear. Now, what do we know collinear means? On the same line. And D is between B and C. So we need to draw this so we can see it. Y'all have got to get to the point where you're drawing these pictures. You've got to visualize this stuff, and most people cannot do it in their head. You got to draw it out. So if we're drawing out points A, B, and C collinear, that means we're going to make a line, and we're going to have 3 points on it, A, B, and C, right? And then what did they tell us after that? D is between them. So based on the information we have, what conclusion can we draw? Based on this information that they didn't tell us. Now, we could say A, B, and C are collinear. Yeah, I know. I'm past 20. 20 didn't get it. It just ain't going to get it. But thank you so much for keeping an eye on the time for me. Okay, A, B, and C are collinear. They told us that. D's between B and C. They told us that. So those are not things we're going to say. What can we say, though? A, B, D, and C are collinear. Or we could say D is collinear with A, or something like that, okay? So we have different options available. Look at number 6. It says point P is the midpoint of segment NQ. So let's draw that. What does that look like? What's that going to look like? What do we start with?
Well, you have to start with N and Q.
So we've got a segment whose endpoints are named N and Q. And then what? P is in the middle. Now remember what midpoint means? Right directly in the middle. So if it's right directly in the middle, what do we know about these two pieces? They're equal. So this has to be equal to this. So what's our conclusion? What is our conjecture? Well, we would say that NP, segment NP, is congruent to segment PQ. See how that works? We're basing this, they didn't tell us this, right? But we're basing this information on the information they did tell us. Y'all see? Okay, look at number 7. Number 7's tricky. Number 7 says angle 1, 2, 3, and 4 form 4 linear pairs. I want you to see if you can draw this. Angles 1, 2, 3, and 4 form 4 linear pairs. I'm going to give you about 30 seconds to see if you can draw it. What's that going to look like? You have any ideas? What you got, Cameron? You got nothing? Did you draw anything? Try something. Did you draw something, Jonathan? Like which one? No, because what are linear pairs referring to? What things are linear pairs? What geometric shape? So this is where you got to use your context clues, right? So we've been doing point stuff up here, point segments, right? But what does the word linear pair refer to? Two adjacent angles that are supplementary. That's why we reviewed that stuff when it's beginning of class. Two adjacent angles that are supplementary. So what's this going to look like? It's two lines crossing. That right there. So if we have angle 1, 2, 3, and 4 that are form linear pairs like this, then our conjecture, there's actually numerous things we could say. One thing is we could say they create two sets of vertical angles. We can't name them because we don't really know which ones are which, right? We could say they are created by lines that intersect. We could say they equal 360 degrees. Y'all see what I'm saying? So there's lots of things we could say about our conjecture here. All right. Number 8 should be simple, but everybody thinks it's really hard. If I just say angle 3 is congruent to angle 4, what conjecture can you make? They're the same size, which means that the measure of angle 3 equals the measure of angle 4. Remember, shapes are congruent, numbers are equal, right? Shapes are congruent, numbers are equal. And measure means the number, right? Okay. So we couldn't make it in 20 minutes. We're going to go ahead and try to finish this up, okay? So on the bottom part here, it says determine whether each conjecture is true or false and give a counter example for any false conjecture, okay? So number 9. If angle ABC and angle CBD form a linear pair. Now, what does linear pair mean?
Two adjacent angles that are supplementary.
So they're adjacent and they add up to 180 degrees, right? Then angle ABC is congruent to angle CBD. Is that going to be true? Is it always true? Can you think of any time when it's not true? Can you think of any two angles that would add up to 180 that are not congruent to each other? Any two angle measures that add up to 180 that are not congruent. Name what angle, Johnny. Any angle. Just any angle. Name a number between 1 and 180. 80? So if he's got an 80-degree angle and Michelle's sitting there beside him and she has an angle and they add up to 180, what would her angle be? It would be 100, right? Isn't that right there a counterexample? So our counterexample would be if angle ABC equals 80 degrees, or the measure of angle ABC, if the measure of angle ABC equals 80 degrees and the measure of angle CBD equals 100 degrees, then they are supplementary, or they are a linear pair, but they're not congruent. Y'all see how that works? Y'all follow what I'm saying? Okay, what part is confusing for you? The counterexample part or the linear pair part? So a linear pair just means that the two angles add up to 180 and they touch. Okay? So if you think of an angle, Anthony, any angle size. Pick an angle. Number. Measurement. 40. What is the angle that would add up to 180 with 40? 140. So you got 40 and 140. Are they the same? They're not congruent, right? So this statement right here, this statement, we're deciding, is it true or false? We're deciding that. And this statement says if they make a linear pair, then they have to be congruent. But they don't have to be congruent, because we can name any two angles in the world that are not 90 and 90 that would add up to 180. Does that make sense? Okay. Number 10. If segment AB, BC, and AC are congruent, then A, B, and C are collinear. I will tell you right now, this is false. And I want you to come up with help me figure out a counterexample. And I'll give you a hint. There are 3 segments. How could those 3 points be where they are not collinear, but they make 3 segments that are congruent? This one's tricky. Non-collinear, but they are congruent. And this B is this B. And that C is that C. And that A is that A. So they all have to sort of connect. What? What would that be called? What kind? If all three of the sides are the same. No, good try though. We haven't talked about this yet. Equilateral. Equilateral. That means all the sides are the same. So any equilateral triangle would prove that that is not true. Okay, what about 11? If AB plus BC equals AC, then AB equals BC. If AB plus BC equals AC, does that mean that these two have to be the same? They don't, do they? So we could say if AB equals 5 and BC equals 1, then AC equals 6. AB does not equal BC. Do y'all see how that works? We're just given any example that proves it's not true. Any example at all. It doesn't matter what the example is as long as it proves it's not true. All right, last one. If angle 1 is complementary to angle 2. Now, what does complementary mean?
Two angles that add up to 90.
They add up to 90. So that means angle 1 plus angle 2 equals 90. And angle 1 is complementary to angle 3. Then angle 2 is congruent to angle 3. Is that true or false? True or false? Are we guessing or we know? It's true. We'll talk about it tomorrow, okay? Bye, you guys.